This documentary is the story of the construction of a power line in a very remote area, and the people who made it happen. This is also somewhat of an outsider's view, an appreciation really of how the big things get done, and especially of the amount of inventiveness and determination this massive project required before it was done. This was a very special project, and mostly because it needed to happen here. This is southeastern Alaska, and this is the Tongass National Forest. It's the country's largest national park, and it's a place of incredible, pristine natural beauty. Rainforests, glaciers, sandy beaches, mountaintops, muskeg, and thousands of islands separated by straits and channels. The Tongass spans literally millions of acres along the southeast Alaska panhandle. It's home to over 400 species of terrestrial and marine wildlife, fish, and shellfish. Some species, such as the brown bear, are endangered in other parts of the United States but thrive here in the Tongass. However, humans also live in the Tongass, and human civilization, although not a large presence here, have always needed to harness the power to provide electricity, and this is where our story starts. Hydroelectric power is Alaska's largest source of renewable energy. If there's one thing you can count on in southeast Alaska, it's rain. In fact, up to a whopping 200 inches a year. Rain is the fuel that runs the turbines. Because the water cycle is an endlessly, constantly recharging system, hydropower is a renewable energy resource, and that brings us to the town of Ketchikan, Alaska, the town that didn't have enough. Ketchikan is located on the southern tip of Alaska's panhandle on Alaska's famous Inside Passage. While a quiet Alaskan seaport community in the winter, Ketchikan is a major cruise ship destination in the summer, welcoming hundreds and thousands of visitors every year. But here was the issue. Ketchikan had a power problem at times, even though they averaged over 144 inches per year. And yes, that's 12 feet of water. The issue was that the Swan Lake Dam, about 45 miles northeast of here, was not always able to store enough for the city's wintertime needs, and so the electric utility had to resort to running two 5,000 horsepower diesel engines to meet demands. However, there was an answer, and it lay to the north across the middle of the Tongass. Up to the north of Ketchikan, the city of Wrangell, Alaska, and Petersburg, Alaska, received their power from the remote landlocked Lake Tyee Power Station. Located about 40 miles southeast, Lake Tyee has 15 square miles of catchment to power the station, so it had the hydropower to share with Ketchikan. But it needed a connection, a transmission line, a high-tension power line to bring Tyee's power down to Swan Lake and Ketchikan.
We own two hydro projects, as you know, the Tyee Lake project and the Swan Lake project. And the Tyee Lake project, we've got about a 75-mile transmission line that feeds Wrangell and Petersburg, and from Swan Lake, we've got about a 30-mile line. This 57-mile link will close that gap, and will be interconnected for the first time from Ketchikan clear up to Petersburg, which is essentially the southern half of southeast Alaska. We have surplus power at Tyee. Meanwhile, Ketchikan's been burning diesels. And so we want to send that surplus hydro project to Ketchikan.
Through the Tongass is the catchphrase here. This was clearly a project that faced huge limitations for the builders because between Swan and Tyee lay all the mountains, passes, islands, and straits of the Tongass National Forest. And Forest Service rules states that no roads of any kind could be built. No roads means nothing with wheels, and the power line construction industry runs on wheels. Lift trucks, puller trucks, digging equipment, rolling equipment of all sizes and descriptions are used to move men and materials to where they need to be. The winning bidder for the project is Wilson Construction of Canby, Oregon. In business since 1952, Wilson specialties include overhead and underground transmission lines, switchyard and substation building, electrical distribution, wind energy resource management, and very importantly, helicopter services. Wilson is a company known for a collaborative team approach to their projects, and so the first order of business was gathering together all of the parties involved to exchange information and make sure they formed the best plan possible.
the inaccessibility of this job and so far from civilization, we literally for 4 years have rebuilt this job over and over, always coming up with a better way how to do something just a little better. We'd meet on a weekly basis, discuss plans, go back, think about them, because by the time we hit the ground here, everything had to be in place.
The remote locations and the lack of any roads means that the Wilson construction managers are facing a mind-numbing level of complexity. They have to design a master plan to accomplish a complex movement of men and thousands of tons of equipment and materials through this wilderness, basing operations from offshore floating camps.
I don't think anybody envisioned how difficult it would be. Being on Forest Service land, we had to do an environmental impact statement. The routing was very difficult to achieve. There were a lot of stakeholders involved that didn't want you to put the line here or put you the line there. So what we got kind of is a compromise that probably wasn't the best place to put a transmission line and created for some very difficult construction, as you know.
The final route design specifies 243 individual pole sites over a 57-mile running length. Near world record spans were needed over water crossings in 2 sections. First at Shrimp Bay with a span of over 4,200 feet, and the longest at Eagle River at a whopping 6,890 feet. Another way to understand the planning challenge is to consider what has to happen at each and every one of the 243 pole sites, remembering that everything that goes in and out does so by helicopter only, flying from barge camps. A year or so earlier, the route itself had been cleared in a 100-foot wide swath that ran from Swan Lake in the south, north to the Tyee substation. Trees that were not taken were left where they fell. The first year of this planned 2-year project is the foundation year, in which from 3 to 6 micropile foundations, plus guy wire anchors, would need to be drilled at each pole site. Later, pile caps would be placed and balanced. The final step was the installation of a unique Wilson-developed device nicknamed the stovepipe, which would be leveled and bolted down. End of year 1. Year 2 and all of the wire stringing, pulling equipment, and pole structures would be prepared and flown into 24 separate locations up and down the line by helicopter. The structures themselves would be flown in by an Erickson air crane and placed on the foundations and later bolted down. Guy wires would be attached, and then the conductor itself pulled through all of the structures. Then the lineman could make the necessary finishing connections. End of year 2 and the project. And this brings us to the beginning. May 2004, Shrimp Bay, Alaska. Crux Subsurface of Spokane, Washington, chosen to provide foundation construction drilling services, has arrived in Anchor Pass. Setting up their floating barge camp is the first order of business. As a base of operations, the camp provides 24/7 crew living quarters, helicopter landing pads and refueling stations, and equipment repair facilities. Crux has long experience making holes in the ground in challenging places, and this project was right up there with the best of them. 2 weeks ago, large seagoing barges began arriving after the long trip from Ketchikan with everything it was going to take to drill and build these foundations. Being this far back in the wilderness means that everything needs to be available from this camp. Forest Service rules would not allow camps on shore, so it all needs to happen here off of these decks. With the barges rafted together and anchored just offshore, water was located and plumbed to the camp. Materials were staged temporarily at an old logging site ready for use. Then helicopters and more crew began to arrive, and it was time to start flying and drilling foundations. Like Wilson, Crux also had to modify and build special equipment that could be flown by medium-lift helicopters. Prior to arriving in Alaska, Crux's fabrication shop had gone into high gear to both build new flyable equipment and also modify new equipment that had been found from a specialty manufacturer. Now it's time to head out. Clearing crews are the first to go out, flying to pole sites both close to Anchor Pass and also at the beginning of the route down at Swan Lake. Where the helicopters can't find a flat place to land, 2 split logs were set up. Then, if the helicopter couldn't actually land, it could place a skid against them and hold station while crews jumped in or out.
Oh, that's a sweet hike. That's a little slice of heaven right there. Tell you what.
They begin by hand clearing the site in order to clear a place for the drilling deck and, of course, remeasure and justify all of the drilling marks. Accuracy here is measured in inches. When they're finished prepping the site, the first A-Star medium lift helicopter arrives, carrying the bare drilling deck, which is lowered and placed exactly on the marks that the crew has fixed. The deck has adjustable legs for horizontal and vertical leveling. Once it's in place and leveled, the adjustable template arrives and is landed and moved into place until the exact center is found. A medium lift helicopter brings in the drill base itself, and then the drill's tower unit arrives, which the crew will assemble on place. After that, the high-pressure air compressor, 3,000-pound power unit, toolboxes, drill rods, smaller decks, and other materials begin to arrive. This is the first transmission project of this magnitude to be constructed using solely micropile foundations. They've been chosen for this project because of their small footprint, which means minimum disruption of the environment. Metal casing is drilled into the rock, then rebar is placed down the middle with centralizers to keep it centered. Then grout is flown in and pumped down the shaft. Around 5 inches of casing is left sticking out of the ground with a centered rebar above that. At this point, things are left to cure. Things are moving. Crews are working successfully up and down the line. Crews finish their work on one site, the helicopters pick them up and move them to the next, and so forth, up and down the line. The rain continues pretty much 24/7, but at least there haven't been any storms that would stop the helicopters, so that was counted as a win. Refuelers from Ketchikan arrive to fill up the helicopter's fuel stores, and like everyone else in this country, they know how to get it done under a waterfall. Perhaps best of all from the Crux perspective is that all of that work, planning and building and rehearsing for this project are paying off. It's working. But then suddenly comes the call that the project has to come to a complete stop. Funding for the project had run out, and that was that. It is uncertain when funding could be reestablished, but there's no hope of it happening quickly. The only thing to do is demobilize, which is a fancy word for let's pick up our tools and go home. And so everybody's now turned their attention to bringing all of the equipment back out of the mountains. So that's how 2004 ended. Crux had accomplished about 60% of the foundation work, but whether or not this project would ever be completed lay with the fates. That and the memorandum of understanding between the relevant parties that should future funding be made available, work would resume. "2005 through 2007 came and went. But fast forward to January 2008, Juneau, Alaska, and the Alaska legislature has approved the funds to restart and finish the project. Now Crux can head back up to finish their portion of the job, but the news had come too late for them to lease a camp barge for the season, so they've decided to have their own built. Even though they're facing a really tough deadline, Lake Union Dry Dock in Seattle, Washington will take the challenge. A retired, very retired, old U.S. Navy YR-86 utility barge has been found and saved from the scrapyard and hauled to Lake Union for a complete refit. While beauty is in the eye of the beholder, beauty's not the point here. This is all about function. At 210 feet long and with a 40-foot beam, she was just the right size for the job. Believe it or not, this old girl is going to be turned into a floating home for over 88 people, and in addition will hold a maintenance and machine shop, management and dispatch offices, and helicopter landing zones. But they've only got 5 months to do it. Crews have been organized on a 7-day work week. Massive amounts of materials are ordered and work is underway. While crews work inside, she's gone into dry dock to have her bottom cleaned and a bottom side paint job. In the meantime, down in Canby, Oregon, Wilson has begun their own massive preparations to be on site next year in January of 2009. Smaller, powerful specialty wire pullers and tensioners have been found in Italy that could, with some serious modifications, be flown by medium-lift helicopters. The new accelerated timeline doesn't give the Italian manufacturer time to make these modifications, so the units have been shipped to Canby, and Wilson's fabrication shop has gone to work to turn them into modularized units that meet the weight requirements.
Well, if we don't get the weight right, the helicopter just frankly won't be able to lift it. It'll stop the job until a larger helicopter can be brought in, which really could be a tremendous delay, because it's not easy to find a large helicopter and scheduling and mobilization for larger machinery. We've scheduled a specific helicopter for this need.
Not all of the planner's ideas work out concerning how to make the massive pole structures easy for the air crane to pick up in the required order. Miniature poles were made to help visualize how to stack the poles. Several ideas were considered, but in the end a rather elegant solution was found, which we'll see later. Now she's out of dry dock and has been renamed, aptly enough, the Alaska Solution. Work continues full bore, but pretty soon she'll be ready for service. It all came together at the last minute, except for a topside paint job. There was simply no time, so function before form. The newly named Alaska Solution needs to be on site in the backcountry right now, and so the tugs are called in. Towed from Lake Union Dry Dock, she transited Lake Union through the Ballard Locks to the Puget Sound. Now she belongs to the seagoing tugs as they hook up for the trip up the inside passage to Ketchikan, where she'll be supplied, and from there into the backcountry. In July 2008, the Alaska Solution is on station at Anchor Pass. Crux is back in full strength, and the race is on to finish all of the foundations and guy wire anchors this year, because next year, Wilson will be here to install the poles and string the wire. Picking right up where they left off in 2004, crews are being flown in, and soon foundations will be drilled in the Eagle River drainage section of the route. This portion of the route has some of the most mountainous and rough country of the entire project. It also boasts the almost record-setting span of wire that Wilson has to accomplish next year, almost 7,000 feet. The crews quickly settle into the rhythm and work progresses, but due to the hazardous nature of the work, no day starts without an all-hands safety meeting. Problems are solved and issues are discussed. Today includes talk about bears.
The bears have never been a problem historically. They're only showing up right now on sites that haven't had a drill rig on them in a long time. As soon as the drill rig gets there, it makes enough noise and dust and activity that they don't screw with us. It's primarily a problem when it's a site that hasn't been visited in a long time. When we show up, the bears lives there or near there, does whatever a bear does, and we're intruding on them.
While there's very little free time when it comes to the helicopters, some trees in the route, identified as becoming a problem in the future for the power line, need to be taken down. The Hughes 500, besides many other activities, is perfect for flying loggers and their equipment to various parts of the route, or at least as close as they can get them.
Inches exactly, even hinge wood all the way across.
August 2008. Work has progressed steadily, and now the cap crews are working high on the route at Eagle River with only a few sites left to finish Crux's part of the project. The rain as usual keeps everybody company, but the drilling keeps right on going, one day blending into the next. The only constant being the drone of the arriving and departing helicopters. Fuel is flown into pre-selected sites so that pilots can refuel more easily without having to return to the barge, saving time and money. Every other day after making a 2.5-hour high-speed trip, the supply boat arrives from Ketchikan bringing food and supplies or whatever was needed. The galley is operating full-time with 2 shifts. No matter how wet or how tired you were at the end of the day, there was a hot meal waiting. Experienced camp cooks are worth their weight in gold, and Pam has long experience in cooking camps all over Alaska. In fact, she's got some pretty interesting stories to tell, if she's got the time to tell them, that is. Outside, the rain is still hammering down, but the end is in sight as the CAP crews progress up the Eagle River section of the route. The final work on any site starts with the base plates that have been prepared on the materials barge and flown out to the site. After placement, the plate is very carefully leveled and then bolted into place. The helicopter returns to the materials barge and brings out the stovepipe, which is also leveled and bolted down. The stovepipe was not part of the original design package and was specifically developed by Wilson for this project to quickly and safely maneuver a pole suspended by a cable 100 feet below the helicopter into the correct position on its foundation. This minimizes the expensive hover time of the helicopter while eliminating the presence of a crew to catch live steel loads. After the stovepipe is bolted down and leveled, the crew is ready to pick up its tools, be picked up, and move on to the next site. And so finally, after 2 years on site and 4 off, all of the foundations and guy wire anchors are finished and in place. The cold season is closing in and nightfall comes a little earlier each day. But Crux's portion has finally been completed despite the start, the stop, the time in between, and the restart. Time for Crux to go home. January 2009. If you're looking for somewhere that's cold and wet, Ketchikan in January is a really good place to start. In fact, January 2009 turns out to be a good month for snow. Wilson's project manager, Kyle Schneider, is in Ketchikan with the staging crew. The shipments of the pole structures are now arriving from the manufacturer. Kyle and his crew's job now is to prepare the battlefield, so to speak, based on the master plan made quite a while ago. And, in a sense, this process very much resembles a military campaign. At its simplest, it goes like this. The center of the project's universe will be the floating barge camp located in the backcountry. First at Shrimp Bay, and then later Anchor Pass. All of the helicopters will fly from, be refueled, and maintained here. All personnel will be housed and fed from here. But none of that is going to work at all unless all of the massive amounts of material are in the right places for the helicopters and crews to reach them quickly and efficiently. It's a massive logistics challenge, and nothing can be missed or forgotten. First, the pole structures themselves needed to have attachments made to each of them so they could be evenly stacked, after which they were placed in a special flying order on seagoing barges and moved to the pre-selected sites. Fire Cove, Clue Bay, Swan Lake, and Upper Carroll Inlet have been selected as land staging sites. Plus, as soon as the tides are right, 3 barges of poles and refueling equipment will be made ready for Tyee itself. So Kyle and crew's job now is to do all of this and be ready to start flying poles by May 15th. Now it's the end of April and work continues with a larger crew. All of the pole structures have arrived and the huge reels of wire or conductor have been sorted and moved to pre-selected sites up and down the route. Preparations include flying the line to check that all the stovepipes are in the correct location and renumbering them with permanent numbers and checking level and tightness of the bolts. Plus, many of the reel stands need to be dug out of the snow. The Alaska Solution, being prepped at a dock in Ketchikan, will be on site May 15th with support barges. A refueling station has been built at Swan Lake with 20,000 gallons of Jet A fuel, and another site holds 30,000 gallons of Jet A and 1,000 gallons of diesel. The last half of May was used for final prep. May 18th, and the Alaska Solution is towed to Shrimp Bay and rafted up with a fuel barge and a landing barge. Everything is in readiness. Poles are staged at all of the pre-planned sites. Fuel stations are built at Swan Lake and at Tyee. And to refuel the air crane, a landing barge and a fuel barge holding 15,000 gallons of Jet A fuel was anchored at Anchor Pass. Back in Ketchikan, float planes, Alaska's taxis, began loading up work crews for the flight out to Shrimp Bay. Expectations are high and everybody's ready to get started. After all, it's Alaska, the sun is out, and there's beauty everywhere you look. What could go wrong? Actually, the weather was always a consideration. This is Alaskan mountain country, And if it gets stormy or the passes got locked in with fog and clouds, that would be a problem for helicopters. However, it's the end of May and the sun was out, and had been for quite a while. And it turns out that that could actually develop into a problem. If the woods got too dry, then the Forest Service could impose what's called a hoot owl restriction, and that would shut the operation down as effectively as a big storm. So everybody keeps their fingers crossed and waits for the arrival of the next big thing, which was the sound of a very large helicopter, and right on time, there it was. The Erickson S-64 heavy lift air crane, also known as the Sky Crane, is powered by two Pratt & Whitney turbine engines, generating a combined maximum takeoff rating of 9,000 standard horsepower and giving the S-64E model an external load lift capacity of 20,000 pounds at sea level. She's 70 feet long. The arrival of the air crane signaled go time to everyone. While every move had been pre-planned and rehearsed, it was time to make sure that all participants were on the same page. Things were going to start to get very complex, and each crew member needed to know what was going on and why. This was accomplished by Kyle's mandatory morning meetings, where the day's work and expectations were discussed and issues resolved. While the nature of Powerline construction with helicopters is obviously dangerous, it was never more so than here in the backcountry.
There's no roads, there's nothing, there's no way to drive there. So all supporters with helicopter, whether one's there immediately or not, you're relying on it entirely. And there's the great potential because of the terrain, the isolation, the heavy lift helicopters, the light lift helicopters working under loads, and just the general nature of Powerline work, especially heavy construction, transmission line work, it becomes quite dangerous.
So the stage is set and everybody's ready to go. This is a good time to see how one of the Wilson's planners' better ideas was going to work. 3 barges rafted together in Anchor Pass with a boom truck in the middle with the pole structure stacked in order of pickup on the one side. Crews attached insulators, guy wires, and travelers to each pole, and then the boom truck moved them to the other side for pickup by the Sky Crane. Another test of the planner's savvy was the ability of the air crane to place that swinging structure over a target about 40 inches in diameter from 100 or so feet up. The stovepipe was not moving, of course, but they certainly were. The stovepipe is an ingenious design that has been built to match the cross sections of the pole, but is narrowed at the top to make it easier for the Sky Crane to thread the needle. The pole settles down around the stovepipe, which also forces it into the correct horizontal alignment and makes a compression fit. And it worked just like it was supposed to, and of course due in no small part to the skill and experience of the air crane crew. Things quickly settled into a rhythm, and unbelievably, the sun kept shining. The native Alaskans in the bunch had a scowl on their face because this just wasn't natural. This kind of weather was not supposed to happen here. But the Tongass kept smiling, and the air crane crew took advantage, and suddenly the project was ahead of schedule.
All that pre-planning is really coming together. This thing is just moving. Originally, we had the Sky Crane scheduled for 5 weeks, and I think we'll have all our steel set in 9 days, all our reel stands in place, all the wire to go. We actually weren't expecting to be pulling wire probably for another month. I believe probably next week we'll start our wire.
In point of fact, it has taken only an astonishing 8 days. Now all 243 structures were installed, plus the air crane had also flown the heavy conductor reels to each of the 24 pre-selected sites and set into the conductor stands that had been placed by Kyle and crew earlier in the year. Now the entire project shifted to the wire installation itself. Now is the time for the journeyman lineman to fly, which introduces the most dangerous component of the project.
Line work in general is extremely hazardous, but when you're in a setting like this, you can't walk from one structure to the next. You have to be flown into every structure. So they've got to be specially trained, skilled guys that are used to working with helicopters. And Wilson's one of the few companies in line work to have their own fleet of helicopters. So this really fit in for us well.
When Tim says that the linemen can't walk to the structures and that they're flown in, he means flown up to the top of the structure, and this is where you see just how important training and experience and specialization come into play. This is not work for the faint of heart, and that might be the understatement of the year. On the other hand, when executed in this manner, it's considered to be perfectly safe. Crews are flown onto the route, and the pullers and tensioners, if not already located, are flown in and assembled. They're then weighted and tied down to whatever can be found to be able to handle the tremendous tensions that they'll need to achieve. They need to achieve line pulls normally assigned to huge puller trucks. Now it was time for another piece of skillful business called flying the sock line. In order to hang wire, you first need to be able to thread and pull a lightweight line called a sock line through the travelers on the poles using a helicopter. The travelers are large temporary pulleys that allow the sock line to be pulled through successive poles. The lead end of the sock line is attached to a device called a needle, and the other is kept tight as it's spooled off a reel on the puller at the other end. The pilot hooks up to one of the two eyes of the needle and then has to maneuver that while keeping it tight up and into each traveler wheel. Then pull it onto the next pole and repeat that same maneuver for each strand. It doesn't take much imagination to picture what could go wrong here, and that's why pilots who fly the sock line are specialists. It takes a light touch and ferocious concentration flying so close to the structures. The puller operator at the other end keeps a slight amount of tension on the line, and as one can imagine, the pilot and puller operator are in constant contact. The middle travelers can be pretty tricky. That's handled by flying the front of the needle up and through the window above the middle traveler, then hooking the needle on the structure, unhooking from the middle eye, then flying around to the other side to hook up to the front eye, reposition the needle to bring the middle eye through the window, and then rehooking up to the middle eye to pull it through. By the end of any given span, the average amount that the helicopter would be pulling was 20,000 feet, or a 4-mile length of rope. At this point, the lead end of the line is dropped down to the ground and attached to the conductor, or a stronger pull rope or two in the case of very long spans. And then the puller back at the other end slowly begins to pull the sock line and conductor back until the conductor itself comes all the way through. Since a single spool or reel can't hold enough conductor to reach the entire pull's length, it's time to see how they're spliced together using a nifty and efficient little device called an implosive sleeve. The implosive sleeve allows both the splice and the wire to be pulled through the travelers, whereas a conventional sleeve or splice cannot. In this case, we're at pole structure 137, and 2 lengths of wire are going to be joined to make the 16,000-foot pole.
From 137 to 155.
Would be about how far?
16,000 feet. 16,800 feet.
Wow.
Well, this is our splicing location where we're splicing the sag portion to the newly strung portion here, and that's an imploded sleeve. So we've connected both ends and we got the implode on there. We're about to set it off, and so it bonds the two wires.
Make a big bang.
We're gonna make a big bang.
Let's go.
5, 4, 3, 2, 1.
Listen to it echo. Listen to it echo.
And this is the result, with the ends of the conductor completely fused together. Now this conductor with splice is ready to be raised and pulled through the travelers to finish the pull. Other than the helicopters constantly landing and taking off, life at the barge camp proceeds with all the activities that keep everybody fed, safe, and rested. Daily deliveries of just about whatever was needed arrived by the daily boat, which made the high-speed 2.5-hour round trip from Ketchikan. Or in emergency cases, supplies were brought in by helicopters or float planes. Of all the diverse activities taking place at the barge camp itself every day, a unique and crucial responsibility was borne by the aircraft mechanics. Flying at 100 miles an hour, 125 feet above the tree line, and hovering close to power line structures all day long makes helicopter maintenance of obvious importance. In fact, the safe operation of all of these helicopters are what make this kind of project possible.
Now you'll be fueling up here.
Every evening, each aircraft is inspected and serviced as necessary.
It's got to be off the deck at 7 again. You know, but to get it off the deck at 7, safety will not be compromised. No way, shape, or form. If it's down, it's down. If I can't fix it, then I'd rather have the boss mad because we don't have an aircraft than it's sitting out there upside down somewhere.
And flying around power lines is more hazardous than most flying.
Tail rotor goes out in a normal aircraft, you got a chance to get into the ground in the power lines, you're done.
The Friday of that week found the mechanics preparing a brand new Hughes 500 engine that had been air freighted into Ketchikan, then immediately picked up and choppered out to the solution. One of the Hughes 500s had experienced engine trouble and was forced to land in a mountain meadow. This engine was the replacement. With the new engine ready and in hand, the crew flew out and made the installation in the field, and she was returned to service immediately. Unbelievably, especially for southeast Alaska, the sun continued to shine. For the normally rain-sodden Tongass, this bordered on mystical, but the crews took full advantage of this gift horse and went for it. By mid-July, the project was a full 6 weeks ahead of schedule. The linemen were flying every day now, removing travelers and installing insulators and making connections. It was now August, and 26.5 miles of conductor had been strung. Half the route done, and this was the point where the barge camp was moved from Shrimp Bay to Anchor Pass. From here, the crews worked the final leg of the route. The portion that holds the longest span, the most rugged terrain, and the longest water crossing. That plus, in these long spans, the wire is 3 times heavier than what has been pulled so far. This Eagle River crossing span will be a near world record, total 6,890 feet, and it will be the one that tests the redesigned lightweight pullers to the max.
You can't pull that with a normal helicopter with steel cable that's strong enough. The pole itself is 15,000 pounds of force just to pull the wire across. So we had to find a synthetic rope that was light enough to fly that far with the Hughes 500, but still strong enough.
The Amsteel rope used was a 3/4 inch braid with a working strength of 60,000 pounds, but only weighs 13.3 pounds per 100-foot length.
So it's just been developments like that to make everything happen the way it is now.
There's a problem that needs fixing on a pole structure not far from the barge camp. It needs to have a guy wire replaced, and the crews come up with a unique plan on how to do it. The volunteer chosen for the job is Rick, a trainee lineman. A 100-foot length of guy wire is laid out on the deck and a bosun's chair is rigged up. The pilot, Andre, nicknamed Rocky, talks Rick through it.
I'll try, I will be the careful I can. And other things, we are up there, maybe it will be windy. If I'm way up in the air, probably will be all bouncing up and down. Just don't rush to do things, I don't rush. So if it takes 10 seconds more, 15 seconds more, 2 minutes more, it's free, you don't have to pay for it. So,
Okay.
You know what I mean?
Everybody's ready. Rick is lifted over and is handed the guy wire, and the lift begins.
The reason we're going to do it this way, it'll save about 4 steps with the helicopter. We can do it in 1 step right now, because we'll have to, otherwise we'd have to fly a guy up onto the tower, he'd have to climb down, get in position.
Just like Rocky said, everybody takes their time, no rush, focus on the objective, and Rick makes the connection and earns a ride home. And that's the way it's done. Given the beauty of the Alaskan backcountry and of course the rather risky business they were involved in, most of the linemen carried cameras. Here's a lineman's eye view of being moved from one structure to another, along with their equipment and the ladder they were working with. Down underneath the line on the Eagle River, Kyle keeps an eye on progress. On the one hand, this pull was a big deal because of its near record length, but on the other hand, all the details have been worked out way in advance.
Went out in the middle.
But despite the long list of all that could go wrong, nothing did. Or at least nothing that could not be solved. And so the Eagle River span was completed, making it the second longest span built anywhere. With the Eagle River behind them, crews were now closing in on the last portion of the route, which is a direct run into the final connection at the Lake Tyee Power Station. This is the station that's going to send the long-awaited power down the line to share with Ketchikan. The end of August was approaching when the crews began to make the final pull of conductor down into the Tyee substation grid. Now the end of this project was really at hand. While the last connections were being made, other crews were busy demobilizing equipment and flying it back out of the mountains. Everything that went into each pole site needed to come right back out again, down to the last scrap of paper or piece of wire. And finally, the day came and the last connections were completed at Tyee, and the last helicopters made their last flights. The project has ended a full 6 weeks ahead of schedule, and all environmental regulations were met or exceeded. Now that the project is done, one can envision all that could have gone wrong or could have stopped or slowed the work. But that didn't happen, and it's mainly because of the massive amount of pure thinking, experience, planning, and cooperation by and between the builders and designers before any boots hit the ground. Now the intertie is complete. Ketchikan joins Wrangell and Petersburg in sharing the abundant hydropower as part of the Southeast Alaska Power Agency.